All right, our last test for this chapter, chapter 9, which means you are going to have a test soon, is on the variance test. So variance test is different in a couple ways. So first of all, when we do the test procedure, it's a chi-square. It's the next table. Again, you'll see that on there, the chi-square table. We have to do degrees of freedom, so we got to go sample size minus 1. The next thing for sample size is n minus 1 is our sample size. S is the standard deviation of the sample. So S is standard deviation of the sample. And theta is population standard deviation. So just to point out those two to you that we'll be working through. Same thing, so reject, do not reject, interpret our example from there. So as we go through it, we'll look at it. We'll go through two examples for you. The first one, cereal manufacturer wishes to test the population variance. Okay, so the weight of the cereal box is this. So they give you the population variance. If they give you the variance, then we don't have to square it. Okay, a random sample of 20 boxes has a standard deviation of 0.25. So we want to test, is it equal to 0.05? So we'd say, and we'll do it this way, we'll just say theta is equal to, so null, is that theta is equal to 0.05. And our alternative is that theta does not equal 0.05. It's a different test or chart that we're using, so this is right skewed. Now, this is a two-tailed test because it is equal. So we want to test our alpha value is 0.05. So we got to divide that by 2. Okay, the difference in this chart, before we just came up with this as a 0.025, and we could say, oh, it's 0.025 on this side and on this side. Now, it will be the same here. So we're going to test here. We're going to find this for 0.025. But for this side, we have to subtract that value from 1. So we're going to look at 0.975 on this side. So we're going to go and look up. We're going to use our chart and to come up with these two. So go to the chi-square chart. On the chi-square chart, this is what we have. Again, our sample size is n minus 1. Our sample size for this case, where do we have it? Our sample size is 20. So we're going to go 20 minus 1, which is 19. And now we're going to go over. So we're going to have 0.025 and 19. So we move over to where these two intersect. So they intersect right here at 32.85. So that's one of them. Then we also have 0.975, so we go back to 0.975. Again, sample size is 20, so 20 minus 1, so that's 8.91. So those are the values that we are going to compare when we get our test statistic. So our test statistic was n minus 1, so 20 minus 1, over our, then we do our sample standard deviation, so this 0.25, and we're going to square it over 0.05. We're not squaring that value because that's our variance. So that equals to 23.75. So I compare it. Is this value bigger than that? No, it's not. Is this value smaller than that, 8.91? No, it's not to the left of this smallest value, it's not to the right of this one. So we do not reject. Do not reject. So again, their question was, is it, wishes to test, is it equal to this? Is there a significant difference between our population and our sample? No, there's not. So we do not reject, saying there's no significant difference. So the variance of the sample is not, or you could say is not significantly different than 0.05. .0, there we go, 0.05. Okay, so the evidence suggests there is no significant difference between those two values. Our second sample, and our last sample, again, have that chart, reference that chart, make sure you're seeing what I'm going through so we don't have any issues there, so we don't have any questions. So here's our second example as we work through it. So I'm going to kind of, the variance of the length of stay of standard deviation of 5, so that's our population. The sample of 39 patients has a sample, so here's our sample. Okay, so what we want to test, suppose the hospital wishes to test whether the variance of the hospital stays with the new procedure is less than the traditional period. So we want to test, is it less than? We're going to assume the opposite. So our null, okay, and our alternative, okay, is that our null is that our theta is less than, so we're going to assume is greater than or equal to what it has been, a 5. And our alternative is that it's less than 5. Again, we want to test to see if it's less than, so that's a lower tail test. It's skewed to the left. We have 0.05. So again, remember, on our chart, 0.05 to the left would be 1 minus 0.05. So if it's to the left, so we're going to test at 0.95. We're going to look up that value. And then we have a sample size of 39. So we're going to go to it. Again, we're using the chi-square test. The chi-square test, if I look at it, I don't have a value, so 39. The sample size is 39. So the 39 minus 1 is 38. So you go down to 38. Now, if it didn't have it, there's some that don't like it. So you can see it doesn't have 33. Just round up. Okay, so if it were 33, go to 34. If it has 38, so we go over to 0.95 and 38. So that's 24.88. 24.88. Now again, that has to be, our value has to be less than that as we go through. So that's what we're testing. It's lower tail, is it less than that value? So now we're going to go through and do our test statistics. So we take our sample standard deviation, 2.84 squared. So our sample size is 39 minus 1 over our sample. Again, we square these two values because they're a standard deviation. If they just gave us the variance, then we wouldn't. Then we test it, okay, and we get 12.2. So is that value less than that value? Yes, so we reject. So we'd say the evidence suggests the variance has decreased from our sample or from our population. So that is our third. That's a test of variance. Biggest thing is the difference is we're using a different chart. So each one of those has a different. So sample, our small sample, we use the t-score. Our proportion, we use the z-score, and then for variance, we use the chi-square test.